Okay, this is our torque lab, and we need to get set up first. You've got your support, which is either black or silver in color. You've got this little clip on here, which should be set at the 50 centimeter mark. If it's not, you can set it there. Get that lined up as carefully as you can. Because we're going to be making measurements to either side of that mark right there. So we'll go 10 centimeters, 20, 30, 40, 50 centimeters in this direction, 10, 20, 30, 40, 50 centimeters in that direction. So when you take your distance measurements, consider that to be 0 and count to the left or to the right. Now you can see that we've got the solo cups out here to kind of help these things from bouncing off the table all the time, because once we have stuff hanging on there, that'll cause the strings to shift. So these are a nice height that allow us to see if it's balanced and without it bouncing around. All right, so first of all, the stick itself is not balanced. So you've got some clay that you can take a pinch of and put it out here on the end that needs to be balanced. And see how that works. Notice how the cup kind of helps to dampen this a little bit. You can even use the cup to... So this side's still a little bit too heavy. You can do a couple of things. You can either move the lump of clay a little bit further in, or you can pinch some of it off. Either one of those things. And I'll give it just another ½ centimeter bump inward. And that looks pretty good. So the first one that I want you to do, part A, is to put 200 grams. We're using these, what we're going to consider massless strings. And we're going to put one string over on this side and one string over at this side. And we're going to hang 200 grams over here at the left, on the left, at a distance of 20 centimeters from the center. So 10, 20. So that's at the 30 centimeter mark here, but it's 20 centimeters from the center. And see, this is where the cup comes in handy, because obviously this side is now heavier. And that cup's going to keep that string from sliding on it. So it's a good thing to have there. And then we want 100 grams on the other side, and we're going to put that at 40 centimeters to the side. You can nudge these things with your fingernail. Just kind of get your fingernail there and give it a little bit of a nudge. All right, so there we go. We're balanced now. And then you're going to record what mass you used and its distance. So this is 10, 20. It's about 20 point, when you look closely there, about 20.3 centimeters to the right. And then this was exactly 40.0 centimeters. So we'll calculate the torques on this a little bit later on. Right now I just want to show you the setups. So that's part A. And you can use different masses, but right now I suggest you just start with that one. The second one, we're going to bump this out all the way out to the 30 centimeter distance. So we're going to push this 10, 20, 30 centimeters out. And then on the right, I want you to switch this to 150 grams. So that's a 100 gram mass. We're going to add a 50 gram mass to that. And you can either clip this, hang this underneath like that. But if it interferes with this thing swinging down, as it appears to be doing, then you can also just hang it right on the string itself. So, and you want to put this where it belongs also. So I'll leave that for you to figure out where this needs to go in order to get this balanced. So that's part B. Part C We're going to do 300 grams over here. So we're going to have the 200 and another 100 hanging over here. But this time we're going to move this, let's take those off. This time we're going to move this way in, so it's only 5 centimeters from the fulcrum. And do that as carefully as you can right there. 5 centimeters from the fulcrum. Make sure that string is kind of nice and perpendicular across the front and the back. And then only using 40 grams, that's these two little, small little 20-gram weights. Only using 40 grams, I want you to figure out, that's kind of a long string. I'm going to switch to this string here, it's a little bit shorter. I want you to figure out where this 40 grams needs to go along here to balance it out, or even if it's possible to balance it out. If it's not possible, then move this out to the 10 centimeter mark and see if you can get it to balance. But start with 300 here and 40 here. 2 20s is a 40 gram mass. That's part C. Part D, I would like you to just come up with your own system, your own combination here, with one expectation is that you have one mass on the left, it could be the 200 for example, but 2 masses on the right. So maybe a 100 and another 100. Okay, so you could do 2 100s and a 200. So you've got 3 different torques. A counterclockwise torque, because it tends to make it want to go this way, and 2 clockwise torques that are trying to make it go that way. So get those to balance out, record their distances, their masses, and we'll calculate the torques a little bit later on. So that's letter D. Letter E, I want you to mass an unknown. So there's a variety of objects over there that you can use as an unknown mass. And so it's just one object. So we'll take one of those strings off. And Buzz here is going to be our unknown mass. In fact, I don't need that string because Buzz comes with his own string. So we're going to hang Buzz on here. We'll put him at the 30 centimeter mark right there. Make sure he's lined up and have him stop swinging while you're figuring out his mass. And then you move this known mass in or out. Obviously it's too far out now because this side's too heavy. So you can either switch to a 100 if you want and get this to balance out. That's too much. You play with it. You figure out what's going to make it work so that you can figure out the mass of the unknown by way of torques. So that's letter E. Figure out the mass of an unknown. Letter G is going to be to find the mass of the meter stick itself. So this one requires a little adjustment. Let's get our unknown out of here. Take this mass off. We'll leave this string on here. But what we're going to do now to find the mass of the meter stick is adjust our fulcrum, which is this metal clip that tightens onto the meter stick. We're going to bring this all the way down to the 15 centimeter mark. Tighten that down. And now what we're going to use to kind of process this, let's move this down here so that the meter stick is going to still stay in view here. We're going to hang the meter stick on, and obviously it's not going to be balanced now because we've got 85 centimeters of the meter stick is only over here and only 50 centimeters is over here. What we need to do now is, using some mass, we need to get this meter stick to balance, on its own. So we can, if 200 grams isn't enough, keep moving it over like this. If that's not enough, then, add some more mass to it. So if we add another 100 grams now, it's too much. So you have to figure out, where does this mass need to go in order to get this meter stick to balance, right? So Just keep moving it over until we get this thing to balance. Once you get the meter stick to balance, you're going to use the torques. The torque of this, the force times its distance, is equal to the force of the meter stick times its distance. In order to do that, we're going to take all the mass of the meter stick. We're going to represent the mass of the meter stick as if it were right there at the 50 centimeter mark. So I'll leave that for you to tinker with and problem solve and see if you can get that figured out. So those are the ones that you do with, that was letter F. Those are the ones that you will do with your own setup and your group of 2, 3, or 4 students. Letters G, H, and I are going to be set up in stations likely at the middle of the different lab tables. And we'll take a look at those next. For letter G, yeah, that's what we're going to be doing now. For letter G, we're going to figure out the mass of this lump of coal. I've got a lump of coal here in a white plastic mesh bag. So let's slide this. I've got it already set up with a little string on it to slide over the meter stick. So we'll add this to this side of the meter stick. I'm going to put a weight over here just to help keep things stable a little bit. I'm going to put this at the 10, 20, 35 centimeter mark from the center. You can put it at different places. I'm going to put it at the 35 centimeter mark. And let's get the cup in there. And then what may not show up on the camera here, but I have a ring stand here. And at the top of the ring stand, let me lower this a little bit so it shows up possibly. I have a pulley. And this pulley is going to hold this string. This black string on the black background isn't maybe the best idea, but it'll work. So we've got the black string. This is going to loop over the meter stick right here. And then this end's got a little loop as well to hold on to a mass hanger. And this mass hanger is 50 grams. And that 50 gram mass will be a starting point, and then we'll add additional masses. Here's a 20 gram mass. We'll add additional masses to help balance things out. So we're going to start with, like right now, the coal is, let's go ahead and put our 200 gram mass. We're going to go ahead and put that at the 20. This is 10, 20, 30 centimeters away from the fulcrum. We'll leave that there. We're going to hang this mass hanger is going to be up front. Let me run this pulley, this string through the pulley. Up and over the pulley, and then onto the meter stick. There we go. Now this is a fairly long string, so I'm going to have to raise the pulley up so that it has an opportunity to hang. So you won't be able to see that, but there's the pulley right there. So I'm going to bring this up and out of the way so that the mass hanger is going to be suspended. And all right, so now the mass hanger will be able to pull on this. Let's get this back on the pulley to cut down on friction. Okay, and then I want the mass hangers just to give it a nice kind of rounded number distance. I'm going to put it right at the 5 centimeter mark. And then we're going to add some masses to it that are going to pull in this direction. So if I add 20 grams, it still isn't pulling it. It still isn't balanced yet. Add another 20 grams, it still isn't balanced yet. If you think you can take one more, there's some 2 gram weights here. We can add 2 grams to it. And that looks pretty decent right there. A little tap sometimes to overcome friction isn't a bad idea. Anyway, that looks pretty balanced. And so now what we consider is the counterclockwise torque of this 200 gram weight at 30 centimeters. The unknown mass of the coal at 35, 10, 20, 35 centimeters in a clockwise direction. And then the important thing to point out here is that although we have a torque on the right-hand side, it is an upward torque because of the string pointed up right here. So just because the torque is on the right, doesn't mean that it is a clockwise torque. So so that is letter G. Okay, so now we're going to do the unknown masses. These are aluminum right here. These three silvery colored ones are aluminum, and this little bit darker color one right here is, so the aluminum ones are the lighter colored ones, and then this darker one right here is steel. And so we're going to try a couple of combinations of these. These are considered unknown masses. And so in letter H, I would like you to put the two of the aluminum spheres over here on the right. And so let's say that we're at, this is just one option. You can put these where you want when you get to this station. This is 10, 20 centimeters to the right, and this is 10, 20, 35 centimeters to the right. So that's an option. And then over here on the left, the 200 is obviously too much. So let's try a 100. And then we can move this 100 until we get this to balance out. You might even want to go to a 50 because that's way in here. So if we bump this down to a 50, we can then swing this out a little bit further and figure out where that needs to go to get it balanced. And then in terms of the analysis, this will be your unknown mass, M. You can call it X if you want. This is also an unknown mass, but these have the same mass. So if we define this as X times its distance, then this is also X times its distance as two clockwise torques for the counterclockwise. So that's letter H. And then for letter I, we're going to swap one of these out. So we'll take out the aluminum one and put in the steel. Well, you won't be swapping it out. You'll be going to another station. But at that other station, you'll have an aluminum sphere, and then you'll have this steel sphere. So for example, in this case, I'll put the aluminum sphere at 10, 25 centimeters away, and I'll put the steel sphere at 10, 20, 30, 40 centimeters away. And then I'll move my mass to get this to balance out. So you'll put that to where it balances out. In this case, if that is unknown M, then this, I can to clue you in on this, I can tell you that this is a 3-to-1 ratio. So if that's M, then that's 3M. Or if that's X, then this is 3X. And with that, you have what you need to solve for the mass of X, to solve for X, which is the mass of the aluminum, and that would be 3 times that. So that would be letter I, and that wraps it up. That's the sheet. When you are done, not with the stations, but with the other stuff, make sure that the masses get returned to their cup. You should have, to the little plastic box, there should be a 200, a 100, a 50, and a 20 in each one of these little boxes. And then the cups can be stacked up. The meter sticks, if no one else is going to be using them during the day, the meter sticks and the fulcrums can be removed, and everything can kind of be returned to the central spot in the middle of the lab table. All right, that's that.